Hello and welcome to 4th grade Unit 3. We're going to be working on division with whole numbers. Make sure you have your note sheet and a notebook in order to be ready for this video. Here we go. All right, the first thing we should talk about is all the different parts of division. If we are writing it horizontally, the first number that shows up is the dividend. The second number is the divisor, and our answer to a division problem is called a quotient. If we have leftover amounts, if it doesn't divide in perfectly, that's called the remainder. If we're writing it in a long division bracket, the inside number is the dividend, the outside number is the divisor, and what you get on top is called the quotient. If you have anything left over on the bottom, that would be the remainder. So a little thing to help you get started with learning division is the little catchphrase, "Does McDonald's sell cheeseburgers?" This stands for the different steps required to do each portion of division. So the first part, does, stands for divide. So I'm going to divide the 5 into the inside numbers, the divisor, or the dividend. Can 5 go into the 1? No. 5 can go into 12, though, 2 times. So then I'm going to multiply. I'm going to multiply the 2 times the 5, and I get 10. I then subtract, because that's the cell. So I get 2 left over, and now I'm going to check. Is 2 smaller than what I was dividing by? Yes, 2 is smaller than 5, so I know I did my math correct so far. And then I'm going to bring down, or if we're working on any of the new methods, we might bring the digit over into a new box. So we're going to bring this 5 down. Now we're going to repeat the steps again. Does, divide. 5 divides into 25 5 times. Then we McDonald's multiply. 5 times 5 is 25. We sell, subtract. 25 minus 25 is 0. We check, is 0 smaller than 5? Yes. And then we bring down, or left over. In this case, we have no more to bring down. We have nothing left over. So our correct answer would have been 25. We're going to practice this some more. All right, our next step here is to learn some different methods. So the one that I was just showing you was called digit by digit long division. That is the way that your parents probably learned it. And it's not a wrong method, but we found that the new way, putting it in horizontal across boxes, helps keep it more organized, and you can do the method the same way. So I'm going to show you how to do this new method. And if you need any extra help, your parents are probably going to be showing you that parent method more often. All right, so we make a big long rectangle. We look at how many digits are inside the dividend, and we have 3. So we're going to break our long box into 3. And then we put each digit in the top right corner of each of those boxes. The divisor goes on the outside. Now, if you're looking at this carefully, you can see, and we'll kind of show it maybe in a different color here, you can see that this is still showing a division bracket here. It's just organizing our numbers a little bit more, and this is where it turns out a little more helpful to a lot of people usually using this method. So now we follow the does McDonald's sell cheeseburgers. We divide. Can 7 go into 3? No. So we're going to put a 0 above here. 0, we multiplied, we subtract for sell. We check, 3 smaller than 7. So this is where instead of bring down, we bring over. That's the only difference in the 2 steps. And now we divide in our center box. How many 7s go into 39? 5. Now we multiply for McDonald's. 5 times 7 is 35. We sell, subtract. So we're going to subtract those. We get 4. Cheese, check. 4 is smaller than 7. So then we burger, bring it over. And now we're going to repeat that process again and find out how many 7s go into 42. 7 goes into 42 6 times. Then I McDonald's multiply. 6 times 7 is 42. I sell, subtract. I get 0. I check cheese. 0 is smaller than 7. And I bring down or remainder, which I had 0. I have nothing else left. So that gives me my answer. And my answer is on the top, just like it would be in long division, the parent method. So we get an answer of 56. Moving on to another method. And again, at any time, please pause the videos, rewatch certain parts of it. If any of these methods don't quite make sense, the more you see them, the easier they get. This next one is called the place value sections method. So in this one, we already have some boxes made for us. And again, we're using that area model that we used in multiplication. Something times 8 goes into this 8,984. So because I have 3 zeros, I know that I'm going to already have 3 zeros in my number. So I can put those under that. And then if I forget about that 984, I'm left with this 8. Well, how many times does 8 go into 8? 1 time. Now I multiply. 1,000 times 8 is 8,000. Now I repeat that process that I'm going to subtract. I get 984 when I subtract. And I'm going to bring that whole number up into the next box. So this is similar to that digit by digit new method, but it is using the whole number versus breaking them into the place values already. So now I have 2 zeros, so I can put those already under the 84. So I'm left with this 9 here. How many 8s go into 9? 1. And 100 times 8 is 800. We subtract that out, and I am left with 184. So we bring that whole digit up next door, 184. I have 1 0 this time, so I was left with 18. How many 8s go into 18? It is 2. So I have now 20 times 8, which is 160. And I subtract that out and I get 24. I bring the 24 up into the next box. And I'm in single digits, so I know that 8 is going to go into 24 with a single digit. 8 goes into 24 3 times. And I multiply it out. I get 24. I subtract it. And I have 0 remainder. So my answer is 1,123. Again, pause the video if you need to rewatch that portion. We're going to move into another new method. This one's expanded notations method. Now, if you are starting to realize all these methods are actually using a very similar process, and whether they're working with the whole number or they're working with only parts of the number. So in expanded notation, we're going to kind of cover up all the digits and only look at one at a time. So we're going to start with this 8 in the dividend. Can the divisor 8 go into that 8? And the answer is yes. It goes in one time. So I'm then going to put zeros above these other digits. So it really went in 1,000 times. And 1,000 times 8 is 8,000. So again, this used kind of the method of our last one, the place value sections method. It's just going to organize it in a different way. So I subtract those out. I get 984 remainder left over. I now am in the hundreds digit. So I look at just that 9. Can the 8 go into the 9? Yes, it goes in one time. So I'm going to put that 1 above that 9's column and fill in zeros above the other ones. 100 times 8 is 800. I subtract that out. I get 184. Now I'm in the tens digit. So I'm going to cover up just the 4, and I have 18 in the tens digit. How many 8s go into 18? 2. And then I'm going to put a 0 in the ones digit. 20 times 8, well, 2 times 8 is 16 with a 0 at the end. Subtract that out, and I get 24. Now I'm in the ones digit, so I look at that whole number. 8 goes into 24 3 times. And I subtract that out. I'm left with 0. I've used all my digits. So now I put a bracket over here and put all these numbers now together, and I get 1,123 is my answer. I always like to circle or box my answer too, so you can find it quickly on a page. Again, there's a lot of new methods we're learning. Feel free to pause and rewatch if you need to at any time for any of these methods. Moving on to word problems. Word problems are probably the hardest part in this unit once you get one of the methods down for division, because in this unit, we really have to understand what the remainders mean in the problems. So I like to use a little term called DABs. First, we drop it. We drop the remainder if you don't need it. This is used when the question asks how many full or whole of something. Then the remainder is not part of the answer. The A, add one more. We add one more to our quotient. So if we have a remainder, we make our whole number one bigger when we're dealing with people or things where we can't just end in parts, or a lot of times if we're buying and we need to make sure we have enough. B, be the answer. This is where you only use the remainder as the answer. This is when they ask for how much is left, how many remaining, how many would be left over, anything of that sort. And the last one, share it. Write the remainder over the divisor. So you're going to make it into a fraction. How many were left over out of how many you were dividing by? This is used in money and measurements. In money, we might turn it into decimals though. Let's take a look at these examples. Maddie tried to divide 148 stickers equally among herself and her 5 friends. There were some stickers left over, so she kept them. How many stickers did Maddie get? So this has a little trick in this question. A lot of times people will do 148 divided by 5, because those are the two numbers they see. However, the trick in this one says that we have 148, so that's our total, that's our dividend. And it says herself and 5 friends. So we actually have 6 people. So we need to divide by 6. Always pay attention to how many people there might be that you're dividing by. So now we can do our method, whatever method you're most comfortable with of division. We get a 2 here. Goes in 12 times. Goes in 4 times. We get an answer of 24 remainder 4. Now, we have to read the question to see what that meant. How many stickers did Maddie get if she got the same amount as her friends and she got all the leftover stickers? So because we divided by 6, every person's going to get 24 stickers. So Maddie gets 24 stickers. But she also gets the leftover stickers, the 4 remaining. So Maddie gets 28 stickers. And I'm just going to abbreviate stickers for now to make our video go faster. So in this case, we had to add our remainder to our quotient to get the answer. Let's take a look at the middle one. Jerry bought shelves to hold 124 DVDs in his collection. Each shelf can fit 8 DVDs. How many full shelves will Jerry have? So I'm going to use a new method here so we can keep practicing our methods. Okay, 8 cannot go into 1, but 8 can go into 12. 8 goes into 12 one time. So it goes in 10. 10 times 8 is 80. We subtract out. We have 44 left over here. 8 goes into 44 5 times. We multiply, we get 40, we subtract out, we get 4. So we have 15 remainder 4. So now we got to read the question and find out what the remainder might mean to this answer. How many full shelves will Jerry have? Well, we're going to have 15 full shelves, and we're going to have 4 on one more shelf. So we cannot count this 4. We have 15 full shelves. So in this case, the remainder was not part of the answer. All right, moving to our last one. Mara wants to buy some new pencil boxes for her pencil collection. She has 29 pencils. If each box holds 9, how many boxes does Mara need to buy? 9 goes into 29 3 times. 3 times 9 is 27. We subtract it out. We get 3 left over. So in this case, because we're buying enough to hold everything, we need to make our quotient have one more. We need to add one more. So this remainder 3 tells us that we need to buy 4 boxes, or we won't have enough space for all of our pencils. So this is going to take a lot of practice. This goes with lesson 3-9. Doing the lesson checks, doing any of the activities that go along with understanding remainders, getting on other digital resources like iExcel can really help you practice the skill of what to do with word problems and their remainders. One of our last concepts is dividing by two-digit divisors. This looks scary, but if you have been practicing the different types of division methods, you really just utilize the same one. Now, we can use what's called compatible numbers to get close to an amount to check and see if we are correct. So for this first part, I'm going to say that 28 is close to 30. And 868 is close to 900. So I might round these to those two numbers to see. If I did 900 divided by 30, I can cross out these zeros, and I find out that 3 goes into 90 about 30 times. So I know my answer should be around 30. So we can divide it out. I'm going to do the digit by digit box method and show you how we can work through these problems a bit. We still have to use the true accurate numbers, but we can use these compatible numbers to try to help with this. 28 does not go into 8. But 28 can go into 86, and you might be like, but I don't know how many times. So that's where we're going to use this compatible number. If it is 30, I know that 2 30s is 60, 3 30s is 90. Well, 86 is close to 90. So I'm going to try 3 times. So I'm going to do 28 times 3 to find out if I can use that number. 3 times 2 is 6, plus 2 is 8. So 3 times is 84, and that's smaller than 86. So I can say that 28 goes into 86 3 times because that would be 84. I'm going to subtract those out, and I'm going to bring that number over. Now, 28 goes into 28 one time. So sometimes we're going to have to do a little extra math when it comes to these kind of problems, because I might not know in my head exactly what a 2-digit number is when I'm multiplying it by bigger digits. So in this case, 868 divided by 28 is 31. Again, these are going to take maybe a little bit more practice. They do take a bit more time than any of our other division problems. All right, now's the time that you are going to try. Try doing some of these problems. If you get stuck, rewatch that portion of the video. Or pause the video now and then resume to go through the answers. All right, welcome back. If we take our numbers 2,748 and divide by 6 using the place value method, we would find out that 6 goes into 2,748 400 times. 400 times 6 is 2,400. We subtract it out, we get 348. 6 goes into 348 50 times. 50 times 6 is 300. We subtract it out and get 48. We bring the 48 next door. 6 goes into 48 8 times. 8 times 6 is 48. And we get 0 left over. So we get an answer of 458 feet. For our next one, we're using that expanded notations method. And I hope you are practicing these methods because they do show up on worksheets, they show up on the test, and the better you have them practiced, the more you understand how all these division methods do work the same way. So the next one, we have 1,232 divided by 8. 8 goes into 1,232 100 times. 100 times 8 is 800. We subtract it out, we get 432. 8 goes into 432 50 times. 50 times 8 is 400. We subtract it out, we get 32. 8 goes into 32 4 times. We subtract that out, and we get 0 left over, so we get an answer of 154 feet. The next one says any method, so I use the digit by digit method. I put the 2, the 9, the 4, and the 5 in their own boxes and then divided digit by digit. 5 goes into 2 0 times. Subtract it out, you get 2. So now it's 29 in the next box. 5 goes into 29 5 times. We subtract that out. We get 4. We bring it over. So we get 44 in the next box. 5 goes into 44 8 times. We get 40. We subtract it out. And then 5 goes into 45 9 times evenly. So we get an answer of 589. Moving down to our first word problem where we have to understand what the remainder might be. We're going to divide the 132 DVDs by how many can fit on a shelf of 8. When we divide it out, we get 16, remainder 4. So we have to look at the question. The question says how many full shelves? Well, we only have 16 full shelves. So in this case, the remainder is not part of the answer. And then again, solving with any method are 2-digit division problems. So 54 cannot go into 6. So I bring the 6 next door. 54 goes into 69 one time. We subtract them out, we get 45. Now this is where I'm going to have to use some of that rounding ability, that compatible numbers to try to figure out how many times. So I move this to 50 and saw this as 450. About how many 450s can 50 go into? Well, it's 9 times, but this number is slightly higher than 50. So I'm going to bump it down 1 to 8. So over here I did 54 times 8, and I got 436, which is smaller than the number that we had, but it's close. So then we subtract it out and we get 16. 16 is smaller than the 54, so I use the correct number. So my answer is 18, remainder 16. Now, a lot of times people will be like, can I have a remainder that big? As long as your remainder is smaller than your divisor, you're good to go. So we could have a remainder all the way up to 53 in this problem. If we get a remainder of 54 or higher, we then didn't divide by a big enough number. This unit had a lot of new concepts. Feel free to rewatch the video as many times as you need to understand these concepts. And practice, practice, practice. Good luck. See you next time.